Welcome back to the channel. Today, we are building something that was financially impossible just a few months ago. We are creating a fully automated cinematic video production pipeline using the absolute cutting edge of AI, Sora 2. Usually, accessing a model like Sora 2 is either restricted or prohibitively expensive. However, I'm going to show you how to access the Sora 2 image-to-video model using an aggregator called Kie.ai. By using Kie.ai, we are driving the cost of this entire workflow, including the video generation, AI music, and multilingual voiceover, down to approximately 25 cents per video. We are taking a simple photo of a cake and turning it into a magical animated delivery scene in English, Spanish, or Russian. Let's build it. We start with the user experience. I've set up an n8n form trigger. To make a personalized video, we need four things: the specific instruction, like a birthday wish, the customer's email, the language selection, and the product image. The language field is critical. We offer English, Spanish, and Russian options here. This will route our logic later to ensure the AI speaks the correct language. I am the digital avatar of Alexander. Need SEO? Get in touch, and my team at SEO Kucha will take care of you. But for custom automation and AI, that is my personal specialty. Check the links below, and let's get to work. Once the form is submitted, we upload the raw image file to Cloudinary. We do this immediately because Sora 2 and our other AI models require a public URL to process the visual data. Before we can prompt Sora 2, we need to understand exactly what is in the user's photo. We pass the Cloudinary URL to Google Gemini Vision. We aren't asking for a simple tag. We are asking for a detailed textual description of the cake, the frosting texture, the toppings, the color palette. This step is vital for grounding the AI. If we want the video to look real, the generated cake in the video must match the actual photo. Gemini gives us that text-based truth. Now we move to the corrector node. We're using GPT-5 Mini to construct the system prompt. Sora 2 is incredibly powerful, but it requires very specific prompting to get that high-end cinematic look. We feed GPT-5 the user's instructions and the Gemini image description. We tell it, you are an expert cinematic director. The courier is an angel. The lighting is magical realism. We are merging the fantasy element of the angel with the factual reality of the cake description. This ensures that when Sora 2 generates the video, the product looks authentic, even while being held by a celestial being. This is the core of our operation. We're using the HTTP request node to send our optimized prompt to Kie.ai. We're specifically targeting the Sora 2 image-to-video model. Why Kie.ai? Currently, they're the most cost-effective aggregator on the market for this specific model. By routing through them, we keep our generation costs extremely low. We send the prompt and the reference image URL. This creates a job. We don't get the video back instantly. Instead, we get a task ID. This asynchronous method is standard for high-end video AI. Since Sora 2 takes a moment to render high-definition video, we enter a polling loop. We have a wait node set to 40 seconds. After the wait, we use another HTTP node to check the status of our Kie.ai task. We use an if node to check if the status is success. If it's still processing, we loop back. We repeat this cycle until the video is ready. This ensures our workflow doesn't time out while waiting for that heavy GPU processing to finish. While Sora 2 is rendering the visuals, we don't waste time. We split the workflow to handle the audio simultaneously. This parallel processing is efficient and keeps the total execution time down. We branch off to handle the voiceover and the music. Let's look at the script generation first. We take the user's selected language from the form, let's say Spanish, and use an LLM to write a script. We strictly constrain the length to about 12 words because we know our video is only 10 seconds long. It has to be punchy. Once we have our Spanish script, we send it to Google's Gemini TTS API. We are using the Zephyr voice for a warm, neutral tone. The API returns the audio data, but n8n often sees this as a raw buffer. I've written a custom code node here to handle the wave headers. We need to ensure the file structure is perfect so that FFmpeg can decode it later without errors. We save this voice file to a temporary directory on the server, keeping our RAM usage low. A cinematic video needs a soundtrack. We use another LLM to act as a music supervisor, analyzing the scene to generate a style prompt, something like ethereal, orchestral, hopeful. We send this prompt to the Suno v4 model. Again, we're using Kie.ai as the provider here. This simplifies our credentials. We use the same API key for both the video and the music. Just like the video, this is an asynchronous job, so we loop and wait until the MP3 is ready to download. While the system waits for these downloads, let's talk about the cost. If we were to use enterprise video generation tools or hire a freelancer, this output would cost tens or hundreds of dollars. By chaining Sora 2 and Suno through Kie.ai and orchestrating it yourself in n8n, the total compute cost for the generated video, the generated song, and the voiceover comes in at roughly 25 cents. That is a massive margin if you're offering this as a service to clients. Now we have 3 raw ingredients in our /temp folder: the Sora 2 video file, the voiceover wave, and the Suno MP3. We use the execute command node to run FFmpeg. This is where we blend it all. We use a filter complex to delay the voiceover by 1 second so it doesn't start too abruptly. We also apply ducking to the music, lowering its volume to 15% so the voiceover cuts through clearly.
An elegant 2-tier cake, ornate and floral. Eat it. Pretend you planned everything.
We upload the final polished video back to Cloudinary to get a clean, shareable link. Then we use the email node to deliver that link directly to the customer's inbox, referencing their original instruction. Finally, we run a cleanup command. We delete the temporary video and audio files from the server. This is crucial for automation hygiene. We don't want to fill up our disk space with old rendering files. And there you have it. We have built a fully automated agency pipeline. We take a raw image and turn it into a premium Sora 2 generated video with custom sound and voiceover in multiple languages. We've leveraged the power of Kie.ai to keep the cost under a quarter per run, and we've orchestrated the whole thing in n8n. This is the future of content automation. Thanks for watching, and I'll see you in the next one.